Now in this video, we are going to take up one more problem. How to analyze this shorted distance problem. So to do that, the problem reads as point capital A is 20 mm above HP and in the first quadrant. Its shortest distance from the XY line is 40 mm. Draw the projections and determine the distance from VP. So to do that, first we're going to take the first quadrant. Since it is in the first quadrant, so VP, HP and RPP. And the point A is 20 mm above HP. So you can see the distance above HP. So that distance, when you look from the front view, is visible in the VP, vertical plane. So since the image is in the vertical plane, so you are going to get A dash. So as we know, the distance from these two is this, is 20. As we are looking from the front view, so this distance is perpendicular to VP. So obviously, this distance is perpendicular to the viewing direction. So obviously, that image will go to fall on the vertical plane of 20 mm. Therefore, you are going to get it as A dash. As we don't know the distance with respect to the in front of VP, but also as we know, as he says it is the shorted distance, always we can see the shorted distance in the profile plane, that is on the right profile plane. In this case here, either you can take the right profile plane or you can take the left profile plane. But for the better clarity, I have taken only the right profile plane. And as we look from the left side view, the image will going to fall on the right profile plane. And this is the distance which is above HP and this is the distance in front of VP. So this will going to form a right angled triangle which is as shown here. Capital A and small a, and to this distance and from here to this will going to be the right angled triangle. So this will going to be the hypotenuse from XY line to this point which is in space, and this will going to be the hypotenuse distance which will going to be automatically the shortest distance. As we know that distance is given to be 40, so from this point to here which is in space will going to be this distance is 40. As I look from the left side view, that image will going to fall on here on the right profile plane. So this distance will going to become R40, and once you get this, so you can mark this as A double dash. Once you get this point, so both A dash and A double dash will going to be on the same line, and as we project this down and then take it to the horizontal plane, and we know that this point from this distance, then you will going to get the distance with respect to VP, which is L will be equal to the question mark. As he has not given any distance with respect to the profile plane, therefore you can take any distance you want. This is how you will be able to analyze this. Now when you go to the step 2, that means I am just cutting it here and then rotating the horizontal plane down and the right profile plane to the right hand side by rotating in counterclockwise direction. And both VP and RPP will going to be on the same line, and HP will going to be below the XY line. So that is how the correspondingly the images will also being rotated. So as we know the distance above HP is 20, so from the XY line you will going to get the distance of 20 mm. And since we don't know the distance with respect to the profile plane, you can take any distance and then draw a vertical line. And as we see, the shortest distance from the XY line is 40, so the shortest distance is always seen in the profile plane, which is RPP. Then from here you measure the distance of 40 and cut an arc on this, and you mark this point as A double dash. So the distance will go to be above HP, and this distance will go to be automatically, it becomes the in front of VP. And then from this point you draw a 45-degree line, and so that it will go to cut it on this particular line. And from here you draw a horizontal projector, and then from here you draw a vertical projector. Both these two will going to intersect at this point, and you mark this point as A, and then you identify the distance between from XY line to the point top view point A. Then you call this as L is equal to question mark. So this is how you will be able to analyze this problem by using the both 3D and as well as the orthographic projection. So to write the final solution, so this will going to be the reference. So as we see, first we are going to draw the XY line and X1 Y1 line by using the sketchbook, and this XY and X1 Y1 line will going to have a thickness little bit higher than that of the projector lines. And then as we see, as we know that distance with respect to the profile plane he has not given, so you can take any distance. and draw a vertical line parallel to the x1 y1 line at any distance. Then by using the then from x1 end you measure 20 mm and then draw a horizontal projector which is going to be a very thin line. Then these two lines are going to intersect at this point. You mark this point as A dash and show this distance as any distance and this distance as 20. Then by using the compass, you take the radius of 40 with the origin as center, cut an arc on the above HP by 20 mm line so that you are going to get A double dash. Then show the dimension of R40 here and show the direction of projection. Then by using the protractor, you measure an angle of 45 degree with respect to the XY adjacent to HP and then draw an inclined line. Then draw a vertical projector from A double dash to the 45 degree line and from this 45 degree line, you draw a horizontal projector which is going to be on the horizontal plane which cuts the parallel line which is drawn previously with respect to the X1 y1 line. And you mark this point as small a and show the directions of projection and show this dimension of 45 degree. Then from here to here, if you measure by using the scale, the length of the scale is going to be 35 mm. The length of this, the distance from VP will be equal to L is equal to 35 mm when you are doing it in sketchbook. But when you are doing it in computer, both in the SolidWorks as well as the AutoCAD, you will going to get the distance up to the second decimal point, which is 34.64 mm. This is how you will be able to analyze the shortest distance problem in first quadrant when the shortest distance is given to 40 and also when the distance of the point is above HP by 20 mm. This is how you will be able to arrive at the solution. Thank you.